Hey everybody, I'm going to do a little bit from 1996 BC2. This was on the handout that you guys looked at, hopefully last week. It gives us a series, this Maclaurin series, excuse me, for f of x. And part A asks us to find f prime of 0 and f, the 17th derivative at 0. F prime of 0 is just going to be, 0 plus 1 over 2 factorial plus, 2x over 3 factorial plus 3x squared over 4 factorial. And I really didn't need to list out these last couple terms because I am going to plug in 0. And hopefully you can see pretty quickly that all the terms after this one are going to go to 0. And so the first part of the answer would be just 1 over 2 factorial or 1 over 2. But before I jump right to the 17th derivative, let's try to look for a quick little pattern. So if I do the next derivative, or we'll call it, the second one, the idea is the 1/2 is going to go away, but I'm going to be left with, 2 over 3 factorial. And then everything else would go away. Again, just because I'm going to use it here in a second, I'd have like a 6x over 4 factorial plus dot dot dot. And so if I took the third derivative, all that would be left would be this. And so on and so forth. And so if you look at this kind of nth term and you think about, well, what would happen with the pattern here? The first derivative, the only thing that was left over was, the constant for the first term. The second derivative, the only thing that was left over was this. And the third derivative, the only thing that was left over was this. And if you think of this 3 as, we think of it as the 6 pattern, it's really 3 factorial. Because what you did here was, if you started with this term, you did 3 times 2 times 1, and then the 4 factorial is just hanging out. And so it's kind of hard. I think this is a hard question. But if you do that 17 times, the idea is that you really care about this term. But it's that term where you're going to take the derivative 17 times. And if you do that, you're going to have 17 times 16 times 15 times 14. You're going to have that. And if you simplify that, which would be 1 over 18, you would get your answer. So, kind of tricky. I'm going to do part B here, which we haven't done in class, and I don't think it's on the test this year. Actually, I know it's not on the test, but it asks, for what values of x does the series converge? And so, one thing that's not on the test is this thing called the interval of convergence. But I'm going to show you how to do it anyway, because I've had a few people ask. And it might help you. It can't hurt you by all means. So anytime you see interval convergence, or what values of x does it converge, or the radius of convergence, we've talked about convergence with just a series, I guess, but not necessarily a Taylor series. But you're always going to use the ratio test. Always. And the ratio says if we take the limit as n approaches infinity of consecutive terms, and it's less than 1, it converges. If it's greater than 1, it diverges. And so one of the things that used to show up on the national exam is, once you have this nth term or ask you for the general term, you're going to apply the ratio test to that nth term. So if I do the limit as n approaches infinity of x to the n plus 1, so this is my n plus 1th term, it will be n plus 1 factorial. And then the nth term is just how it appears in the initial question. So you might have to do the ratio test this year, but it would probably be without x's. That's, you know, you're doing it for some from series that's already been defined. What we've talked about is usually my initial step is to rewrite this without a complex fraction. So I'd have like n plus 1 over n plus 2 factorial, and then times it by the reciprocal. So you have something like this. And so, I'm starting to get a little crooked. So we've talked in class about simplifying this, and I hope you pause the video and try to simplify it before you're just spoiled with it. But it takes a little bit of experience. But if you do simplify this inside correctly, you're going to end up with an n plus 2 on the bottom, using rules of factorials, and just a single x on the top. Just looking at this piece right here, you have one additional x on the top, so all the other x's would cancel. The only difference with the ratio test for these Taylor series type things is you have to keep in mind, this is the hardest thing, is that when you're taking the limit, this x, you've been told your whole life that x is a variable. It's the most common variable in algebra. But in this particular context, x is a constant. Or you're going to treat it like a constant, because you're taking the limit as n approaches infinity, which means that when you take the limit of a constant, it doesn't affect it. When you take this limit, we want to know what happens as n gets really, really large. One thing that I tell students is you can think of this as almost pulling the constant out of the limit. So pull the x out in front, because you're only going to be taking the limit of things that have an n in them. And so you could really treat it like this. Now, what usually happens is the limit at the end is a L'Hopital's, or it's a degree, or it's those things leading coefficient. This limit, you should know, goes to 0. And this end is actually really nice, because 0 times anything, no matter what value of x it is equal to 0. And the ratio test over here says that if it's less than 1, and 0 is less than 1, then things converge. This was kind of a unique example because there's no restrictions, because it's always less than 1. I'll try to do another example at some point where it's not always less than 1. But in this case, it's going to converge. Can't spell. For all values of x, because it's always less than 1. Sometimes we call this absolute convergence, if you see that buzzword show up. It didn't ask for an interval of convergence, but if we were to represent it as an interval, that interval would be every number. So if you've looked at some of the rubrics for older questions, I almost started writing rubric. The interval of convergence for all values would be in negative infinity to infinity. All right, I'm going to do letter C here because we got some time. It says let g of x equal x times f of x. All right, we're going to find g of x. So what I'm going to do is I'm going to take the series that's given. And if you forgot, it's 1 plus x over 2 factorial plus x squared over 3 factorial plus x cubed over 4 factorial. And when you have a product like this, whether it's a variable or a number or anything, you can just distribute it in. So g of x would be x plus x squared over 2 factorial plus x cubed over 3 factorial plus x to the fourth over 4 factorial, etc. So that's actually the first 4 terms. The question actually only asks for the first 3, but then it asks for the general term. And so, depending on how you want to write this, there's some patterns in here. You could think of this as 1 factorial if you wanted to. And usually we treat this as like the 0th term, the first term, the second term, etc. So if you plug in 0 and you want the bottom to be 1, you could think of the bottom or the general term as an n plus 1 factorial. And then on the top, you have these x's. Then the other thing to kind of look for is how this is related to the exponent. In this instance, they're the same. So you could put the n plus 1 up here, and that would be the general term. All right, letter D says write g of x in terms of a familiar function. So I'm hoping that it kind of looks like this. I don't think they're going to ask you something like this because they cut out half of the units on Taylor series. So this gets a little bit crazy. But we know that e to the x, or hopefully that's one of the common ones that you should memorize, looks like this. And the thing you found, g of x, looks like this. And so I think you could think of, and it's not really a natural way of thinking, but you could think of g of x as e to the x, because it's really, really close. I mean, except it's missing this 1. And so, is that what it's asking for? Right, g of x in terms of a familiar function using series. Then write f of x in terms of the same familiar function. So just we keep going in circles. So f of x, which I lost track of what it is. I think f of x was this. So it looks like everything's off by like a power of x or something. So with f of x, you have that these don't match up. Oh, I should have picked a different color. And with g of x, you have this. So I think you could take f of x and say that it looks like g of x, but you're dividing by x, so you'd have something like this. This is, again, beyond what I think you need to know, but I think that's the idea of what it's looking for. So don't worry about it too much. Don't freak out about it too much. I'm not too worried about it. The only thing I would say is that there's something up here with if x is 0, then you have a problem. So you might have to say something about that at the end. But this goes a little bit beyond what you need, but if you could follow most of that, just kind of keep up with some of the notation, I think the more you can look at it, the better. So thanks for watching.